So my experience is, I'm not purely from an analytics background. I've had a fairly varied path throughout my career. Started in IT services, then switched to open source as an open source developer, then later went for higher studies in computational science, scientific computing, that sort of thing. And then back to analytics, and the last 6 years or so, my focus has been around building and bringing more engineering mindset into building analytics solutions at Tiger. I incubated and built the MLE practice at Tiger, and the current challenge is essentially how do I scale this across the org, right? So that's the plan, and the talk is essentially around how do we bring reliability, right, into AI solutions. So when we saw a lot of metrics today, right? I'll add some more numbers. I didn't want to put the citations because a lot of these numbers are questionable, right? It depends on the research methodology, it depends on what you define as success criteria and so on and so forth. But I think the sentiment is real, right? Which there is a sense of fatigue, right, with respect to both the sponsors as well as the builders with respect to taking AI solutions into business critical systems, right? A lot of projects end at the stage of a POC. They don't make the cut into production. In fact, a lot of the conversations today has been a validation of that thought process. I've generally heard a similar sentiment that there is a question about reliability in AI. Can we even bring reliability into AI, right? Is it even feasible, or are we headed into another AI winter, right? I choose to be optimistic. I think this is a fairly unique point in history. There is a fairly unique confluence, right, of innovations in AI, innovations in technology, availability of cheap compute, huge investments into the space, and more importantly, right, the willingness of people to adopt AI and the demand for AI, right? So all of this looks like a perfect storm for adoption of AI, right? But can we make it, right? And so in fact, this is not a new problem, right? My optimism comes from the fact that this has actually been done multiple times before, right? So if you look back at history, so think of, let's say, the aerospace industry, right? From the time when flight was deemed possible to the time that we are willing to trust and board into an aluminum tube and fly 6 miles above the ground, and we don't think about it, right? We just trust the technology. It's been a long process, right? It took a fair amount of time for this technology to mature, to stay where we are able to trust it without thinking about it twice, right? And this was well before the advent of modern compute and so on and so forth. And system engineering, right, is essentially a discipline that was brought about to make this change happen. It basically, it's not a technology, it's not a very prescriptive solution, but it's essentially about the engineering process, the engineering rigor that is needed to take a collection of components which may have a lot of uncertainty, but then build a system that can behave predictably, right? It's not about reducing complexity, right? Complexity, there's essential complexity, there's incidental complexity, right? Essential complexity is not something you can remove. It is part of the problem. You have to manage it, right? Now, there is a well-defined path. There are a lot of techniques and methodologies around how this is managed, right? For instance, one of the core aspects is essentially rigor in requirements, right? For instance, if you take a parallel to today's requirements, right, a lot of them look like a list of wish list, right? There is no specification. It is not testable. It is not measurable, right? A systems thinking would be essentially about, given a set of requirements, how do I make it closer to a formal spec, right? By formal spec, I mean it should be measurable. I can I can clearly say whether I have achieved it or I have not achieved it, right? Then once you have the requirements, you have this design process, which is essentially designing to the specific requirements that have been created. Then you have deployment, and then V&V stands for validation verification. These are the key pillars. There are more, but these are the key pillars. And the whole idea is essentially to have an iterative process where you consistently measure your system, refine your specifications, do the verification validation, and continuously improve the system, right? Verification validation stands for, well, verification stands for essentially, have you built the thing right? You have a formal spec, have you built it, can I test it, it corresponds close to your unit tests, and so on and so forth. Validation is essentially, are we building the right thing, right? It is essentially, I may have a conceptual idea of what I wanted to build, but is it what the end product is, right? And that comes from user feedback and based on analyzing the usage patterns and so on and so forth, right? Now, over a period of time, right? For instance, NASA has achieved, for instance, 99.9% reliability in aerospace and defense, right? That's an amazing number, right? But this took a very long time, right? Does it mean that every such innovation has to go through such a long process? And does it also mean that this is very, very specific to aerospace or hardware and does not apply to software systems, right? That is not true. In fact, there are plenty of examples where formal methods have found their way into software development, right? And companies with large technology companies and companies with strong engineering cultures have taken advantage of that to build extremely reliable systems, right? I'll not go through all, but for instance, an example could be formal verification, right? This is typically considered to be an academic technique, right? Not practical and so on and so forth. But with the kind of extreme scale today that we have, the kind of distributed systems we build, it is not possible for a person to think through all the scenarios, right? It is, you need a formal system, you need a model of the system in order to be able to even think carefully about the implications of the system that you're building, the emergent behaviors in the system, and so on and so forth. It is not going to build your solution, right? But it is essentially about streamlining your thought process and simulating different scenarios to understand the behavior under different conditions. And once you understand the failure scenarios and so on and so forth, you could go ahead and use your standard boring technology to handle or make the system reliable in those areas, right? Another example could be chaos engineering, right? This is essentially the idea of introducing faults into your system to see how your system behaves, right? Now, a reliable system doesn't mean that none of the components fail, right? It means that some components can fail, but as a system, your system behaves in a predictable manner, right? It does not have a catastrophic outcome, right? And that's the key idea. And one way to test this is to purposefully introduce defects into your system and see what happens, how do errors propagate, how do failures propagate, where systems fail, and so on and so forth, right? Again, right, so, but again, right, the adoption has been in groups that have a strong engineering culture, and they adopt the system thinking practices and so on and so forth, right? However, if I come to our industry, right, we are in data and AI services, the adoption is pretty poor, right? My own experience, right, is I had, it was quite challenging. When I joined Tiger as part of the data science team, I was an odd duck in the group, right? I come from a startup world and so on, where people do multiple things, and then you look at the service industry, and suddenly you have all these siloed groups focusing on individual aspects, and there is no single owner for the solution. There is no one person looking at the overall system, and so on and so forth. And it's a real challenge that I see in a lot of the companies, right? Very siloed developments. No one has a clue. No one has the idea about the overall system, the behavior, or the ownership around it, right? And the predominant challenges are, one is the cultural resistance. People are used to doing things in a certain way, and there's resistance to change, right? I really like this metaphor of organizational antibodies, right? Whenever there is a change that's introduced into the system, there's always resistance to change, right? People are not entirely sure, and change can be good, but change, the safe thing to take is to reject the change, right? Then there is also the challenge of skill gap, right? It is not easy to bring systems thinking, and scale it across the org. When you're operating at scale, it is a challenge. In small teams, small groups, you could do that, but how do you scale this to larger groups? That's a key challenge as well. And then, of course, right? So we all know, there's a severe resource constraint. We operate under heavily compressed timelines. The expectations from clients versus on the capabilities of the AI versus the actual capabilities of the AI on the ground are, there's a significant mismatch. So one of the first victims, anytime you have such pressures, is the engineering rigor, the engineering practices. They're generally seen as blockers to innovation, unnecessary bureaucracy, so on and so forth, right? And yet another statistic, 70% of organizations struggle to adopt formal engineering process. So it's not like a new thing, it's not a new idea. This has been going on for some time, but the adoption challenges exist, and it has not been very successful, at least in the data and AI services industry. So how do we do that, right? Now, it is not a technology solve. It is not about mandating that people start using certain practices and show efficiencies. Wherever this has been, we've seen clients where suddenly people have given access to Copilot and are asked to show certain efficiencies in their process, right? And typically these don't work well. So the key thing here is to not look at it as an individual problem. It is not just about using tools to accelerate. It is essentially about transforming your culture, right? And it is a combination of tools and technologies, the people, and the process that you follow. All three has to be looked at together and responsibly moved to achieve in the direction that you want to move your culture towards, right? What can the organization do, right, to support this? So this is one of my mandates, one of the things that I'm thinking a lot about these days. One aspect is to basically build internal platforms, right? Now, it's not a new idea. Internal developer platforms have always been available. But the idea of removing the friction, right, in adopting good engineering practices, in my mind, providing happy paths, golden paths for people to quickly get the job done without going through the friction of looking at all the different tools that need to be integrated and so on and so forth. At the same time, a lot of these good practices could be baked in, and these paths could help them build solutions with good quality without going through the friction points, right? And this also brings together the org, set up inner sourcing as a strategy, where, again, right, this is again to break the silos, right? There are different groups building very similar things in different pockets, right? Now, by enabling an internal platform and building common infrastructure, common services that people could reuse, and inner sourcing it across the org, and encouraging people to reuse components, contribute back to the components, and along the way also leverage other stakeholders like your L&D teams and other folks to conduct dev days and hackathons where the practices that you want people to adopt are made easier for them to try out in a low-stress environment. And the other aspect is to essentially have very clear guidelines around the usage of AI, right? And has been a challenge, right? You get very different messages from different parts of your organization, right? The InfoSec says, sends very severe-looking messages about the usage of AI. At the same time, your team leads may be telling about how AI, if you're not augmenting yourself with AI, you're going to get outdated, right? So what does a person do, right? So in fact, there's a there's a term called shadow AI usage, right? That's getting popular. Again, the idea is that people are using AI, but they don't openly share about it, right? And it is an organizational risk. At the same time, you're also losing out on, bringing the adoption of these tools and practices into your organization. So what organization can do is ensure that the entire organization is behind a very clear single message. Ensure that everyone, including the leadership team, is using these tools, and that is being openly visible to people, which basically gives a very clear message that the whole org is behind, and this is the right thing to do, right? The other aspect is also, right, I've heard a lot of mention about using AI to reduce cost, right? I think that is a wrong message to give, right? In fact, I think a better message could be to say that, or at least from a cultural perspective, a better message would be to say, we want to use AI tools to unlock productivity, to build higher quality for the same cost, right? I think that's a more aspirational message, as opposed to race to the bottom of the lowest cost of development. And I think that is a vicious cycle that you would want to avoid. And of course, right, there are more approaches, right? Like I said, right, it's not just a technology solve, it's also a social solve. So you want to make sure that there are communities of practice that are talking about this tool usage. There are a network of champions that are pushing forward the message across their peer groups and so on and so forth, right, and so on. So what are some key levers, right, for systems engineering that I think of, right? There are many probably, but I just picked a small set. I think one key thing is going to be formal requirements, right? In fact, a lot of projects that don't make it to production are predominantly because the specification is not clear, right? It's not clear what the client wants. It's ill-specified, and what you get out of, at the end of the day, no one is happy about it. Then there's the whole iterative model, V model, which is actually nothing but continuous testing, continuous improvement. For instance, we build models, but the evaluations process, continuous learning process, that is not that's not well defined, at least in the case of GenAI solutions and so on, right? And then, of course, things around risk management, safety analysis. For business-critical systems, particularly in regulated industries, what are some compliance issues? What are some challenges? How do you proactively prevent them? How do you proof your system around it? You may not be able to avoid a failure, but you may be able to have backup behavior. You may be able to have failover behaviors and so on and so forth. Right? And then, of course, performance metrics, right? It's ultimately, unless you measure, things are not real, right? You can think you have a good solution. You may think it's a performance solution, but unless you have the clear metrics that measure very specific properties of the system, it's not real, right? And it's all not theoretical. In fact, in Tiger, we have a capability group who have been playing around with building a next-gen platform. We have started using it internally to see, with smaller groups of people, to see how we can improve productivity and so on and so forth. And there's also a lot of interest from our clients, right, who have tried adopting external tools but have not seen the successful adoption, reaching out to us to see how we can enable this for them, figure out a roadmap, and build the solutions for them internally, right? Just to make sure that it's not just a theoretical construct. We are seeing real interest and so on and so forth. So in my mind, right, this is a key opportunity, right? Which is, if I just go back, right? So There's one aspect of it which is, I'll just go here, right? So there's one aspect of it which is, we know bringing in better engineering practices is going to make your solutions more reliable, right? But the adoption is challenging because there's significant friction in adopting these tools. So then, can AI-assisted engineering be a way to bring, to make adoption of these tools much easier, right? So that's the first key idea. The second key idea is, once you build that adoption layer, can you add intelligence into your engineering layer to further accelerate the development of AI itself, right? For instance, rather than throwing away existing tools and completely adopting new AI frameworks and tools, can you take existing tools, add a layer of intelligence on top, and then use that to further accelerate your process? And again, as I mentioned, right, mandates don't work. The important thing is to start small, identify key pilot projects, identify your champions group, and then get the message around, build this assisted toolkit, and start small, get the system working, show value, and then use the organizational support and so on to scale it to the larger org, right? So that's the general thought. I'm very curious to hear your thoughts. I'm sure all of you are facing similar problems. What has worked for you, what has not worked for you, please feel free to catch me up. I'll be at the Tag Analytics booth today and tomorrow. Thank you.